Hi, my name is Richard, and in this video, I'm going to demonstrate how AWS creates an application load balancer, or ALB, for a Kubernetes Ingress resource. In an application load balancer, traffic is balanced at layer 7 of the OSI model, instead of layer 4 when using a network load balancer from creating a service. This is another example of how to enable external access to web services deployed to a Boomi molecule deployed in EKS. An Ingress resource may be configured to give internal services externally reachable URLs, load balance traffic, terminate SSL, and offer name-based virtual hosting. The difference really is that application load balancers are typically used to balance HTTP and HTTPS traffic and provide more advanced request routing. To enable the integration between the EKS cluster and AWS, to create the application load balancer, you need to deploy the AWS load balancer controller in your cluster. AWS provide detailed instructions on how to deploy their AWS load balancer controller if you do not already have one provisioned. Using an Ingress first requires creating a service for the molecule. The service does not need to be available outside the Kubernetes cluster, so we can create it as a type node port. Here I've created a service for the default Boomi web service using HTTP on port 9090, with the service also listening on port 9090. Once I've deployed the service, I can describe it to verify that the endpoints match my existing molecule pods. Now I've confirmed the service looks okay, I can deploy the Ingress. But first, let's review the Ingress configuration. Here we can see my Ingress resource. I'm creating an Ingress class name of ALB for an application load balancer. To direct my HTTP traffic, I'm using a simple rule to send all the incoming requests to my service on port 9090. Ingress rules can be much more complex, and you should refer to the documentation for more information. I've also added several annotations which are used by the AWS Load Balancer controller to configure the ALB that it creates. More information on these can be found on Amazon GitHub page for the AWS Load Balancer controller. Applying the Ingress resource will create it. We can get the details to see the address of our application load balancer. We can describe the Ingress to confirm the events show it was successfully reconciled. This means that the Amazon Load Balancer controller has started to create it. Now we move over to our AWS console, where we can see the load balancer type of application has been created and is active. Looking at the configuration, I can see that it is listing on port 80 with two rules for routing traffic. The last rule is a default to return a 404 response in the event no other rule is matched. The first rule is the one created from our Ingress to forward traffic to a target group. Where we see 3 healthy targets and the registered targets and the port numbers should match the running pods. Now I can use a Linux command such as curl to test the load balancer and ensure I can reach the molecule web service. The simplest place to start is by checking I can reach the _admin status endpoint and confirm I'm getting a 200 response. Now that I've confirmed the application load balancer is working, I can move on to deploy and test other web services on my molecule. I have a simple web service deployed that returns some properties about the process and environment. Using this process, I can verify that it did indeed run on our molecule and on molecule node 2. Refreshing the page a few times, we can confirm the molecule node changes, confirming the load balancer is working. Hopefully this example will help you in configuring an AWS application load balancer for access to your Boomi molecule web services. Thank you for watching.